Hi friends of geography! This video is going to inform you about the atmospheric circulation of the globe. Let's start with the question why there is high and low pressure and where it occurs. Because of the difference in the sun's radiation, there are different pressure zones on Earth. At the equator, the sun's radiation is most intense and the air warms up and rises. Because warm air is less dense, the air pressure is low. Around the poles, the sun's radiation is very low. As you know, it is very cold. Cold air is denser, so there is a high pressure area. At the equator, warm air rises. The air is forced north and south because the troposphere does not allow a far upward movement. At around 30 degrees north and south, the air has cooled down and sinks again, causing a high pressure zone. The air warms up. Warm air can hold lots of moisture, which is why there is little rainfall here. In fact, the world's biggest driest deserts can be found around the tropics of Cancer and Capricorn. The warm air then moves back to the equator, where there is a low pressure zone. This circulation of air moving from the equator to 30 degrees north and south and back to the equator is called the Hadley cell. From the high pressure zone at the subtropics, the air moves to about 60 degrees, because the air wants to balance out differences in pressure. Then the air rises and moves back to the subtropics, where it sinks again, so the Ferrel cell is formed. Between the Hadley cell and the Ferrel cell are the so-called horse latitudes. They are also called the subtropical highs, because they are located at 30 to 35 degrees north and south of the equator. As already mentioned, there are high pressure belts and there is little precipitation. There are only weak winds at the horse latitudes, because the air in the Hadley cell moves southwards and the air in the Ferrel cell moves in northern direction. The air sinks at 30 to 35 degrees, so very weak winds occur. Due to these warm and dry conditions, many deserts can be found at the horse latitudes, for example the Sahara, Atacama and Kalahari Desert. They are also associated with the subtropical anticyclones. Maybe you're wondering why these areas are called horse latitudes. In former times, sailors gave the regions the name because ships relying on wind power stalled. They couldn't take much fresh water with them, but if there was hardly any wind for several days, they were forced to throw their horses overboard in order to have more water for themselves. A circulation like the Ferrel cell also takes place at the poles, where cold air moves from the high pressure zone at the pole to the low pressure zone at 60 degrees. Because of the Earth's anti-clockwise rotation, air is deflected to the direction the wind is blowing from. This is called the Coriolis effect. Due to the Coriolis effect, the winds from the subtropics to the equator are also deflected. These are the strong trade winds, which are a result of high pressure at the subtropics and low pressure at the equator and develop closely to the Earth's surface. The northeastern trade winds are found on the northern hemisphere, the southeastern trade winds on the southern hemisphere. In the colonization time, European settlers sailed with the help of the trade winds to America. They traded goods, commodities, slaves and a lot of other things. The westerlies blow from the high pressure area at the subtropics to the low pressure area at 60 degrees and come from the west due to the Coriolis force. The easterlies are found at the poles moving from high to low pressure. They are the strongest winds and deflected most. Because these two winds are coming from opposite directions, there is a high temperature difference when they meet. This is called the polar front, which forms the border between the polar and the Ferrel cell. In this area, storms and winds occur with speeds up to 300 km per hour. On the Earth's surface, these winds are deflected and slowed down by the friction force. Now we will tell you something about jet streams. There are two types of jet streams, the polar jet stream and the subtropical jet stream. They are in 10-kilometer altitude and airplanes use them to fly faster. The northern polar jet stream strongly influences the quickly changing weather conditions in North America and Europe. Because of the Coriolis force, they move westwards on the northern hemisphere. If the differences in temperature and pressure between the poles and the equator become too great, the jet streams begin to wobble. The Earth's surface, for example mountain ranges, plays a big role too. The speed of the jet stream increases and areas of pressure and suction can develop. So guys, now you're done. In this video you learned a lot about high and low pressure on the globe, the different cells, the Coriolis effect and different kinds of winds. The easterlies, the trade winds, the Hadley cell, the westerlies, the Ferrel cell, the jet stream and the polar front. Thanks for watching guys! In the colonization time, European settlers sailed with the help of the trade winds to